Hello, this time we are going to learn how to calculate the rate of reaction. To calculate rate of reaction, we have average rate of reaction and instantaneous rate of reaction. Average rate of reaction can be explained by when a car intends to travel for 400 km. Due to the ever-changing traffic conditions, the driver is not able to maintain a constant speed and took 4 hours to reach the destination. The average speed of the car is 100 km per hour. Instantaneous rate of reaction. Situation, a police official aims the speed camera in the direction of the car because it is traveling at a speed above the speed limit. At that instant, the camera recorded a speed of 140 km per hour. So the speed at the moment is equated to the instantaneous rate of reaction. Average rate of reaction is the average value of the rate of reaction that occur in a particular time interval. So kita ada contoh kat sini, the overall average rate of reaction is equal to the total volume of gas collected at time taken. For the overall lah untuk reaction keseluruhan. Bila dia tamat, kita ambil total volume gas yang kita collect sehingga eksperimen habis dan bahagikan dengan masa yang diambil untuk eksperimen itu habis. Okay, example. The table shows the total volume of hydrogen gas collected at regular time interval for the reaction between magnesium and nitric acid. So this is the time taken and the gas volume produced at certain time. What is the average rate of reaction? So soalan tanya average tu maksudnya keseluruhan lah. Okay, first kita tengok reaction stop at time. Kita ada dua kat sini, at 90 second and 120 second, the gas volume is 30 centimeter cube. So, this reaction stop at 90 second actually kan. Formula used is volume of gas produced divided by time taken. So, 30 centimeter cube divided by 90 second is equal to 0.33 centimeter cube per second. Average rate of reaction yang kedua is the average value of the rate of reaction that occur in a particular time interval. Example here, the average rate of reaction for the first second is equal to total volume of gas collected in the first T second. T second tu maksudnya in the first minute ataupun in the first second minute, in the first third minute divided by time taken. Okay, so ini tak ada maksudnya dia tolak dengan kosong sajalah. Okay. Alright, next. Average rate of reaction in a particular time interval. So the punya formula is total volume of gas collected from T1 to T2 divided by time taken. Example here, kalau dia tanya what is the rate of reaction at second minute. So at second minute means that second minute kena tolak dengan first minute. Okay. Data second minute tolak dengan first minute. So that's why kat sini volume collected at the second minute tolak volume collected at the first minute, and then time second tolak dengan time first tadi. Okay. Contoh. The table shows the total volume of gas collected at regular intervals in a reaction. Okay, what is the average rate of reaction in the second minute? So second minute bermaksud ini minit yang pertama, second minute 120 lah. Okay, so means that second minute 120, yang ni kita akan tolak dengan first minute 60. Okay, jadi okay, 6.4 minus 3.7 over 120 minus 60 is equal to 0.045 cm cube per second. So second minute ni kena tolak dengan first minute lah. The characteristic of the instantaneous rate of reaction. Number 1, rate of reaction at a particular point of time. Number 2, it is determined from the experimental data by plotting a graph of changes in the quantity of the reaction or product against time. Number 3, measuring the tangent gradient to the curve at the point of time. Number 4, there are several steps to calculate instantaneous rate of reaction. So next we are going to see step how to calculate instantaneous rate of reaction. Method number 1, we should draw a tangent to the curve at time t. Time t tu yang ditentukan lah. Okay. So lukis tangent gunakan pembaris dan pensel. Okay. Kemudian we use the tangent to complete a vertically angled triangle. So daripada tangent tu, okay, daripada tangent yang kita lukis ni tadi, kita akan lukis segitiga. Okay, dia kat T time tadi. Okay, lukis segitiga. The triangle can be drawn in various sizes. The bigger the triangle, the more accurate it can be to determine the tangent and gradient. So macam mana nak lukis tangent? Lukis tangent ni, okay, kita tengok dekat point kat sini. Panjang tangent di sebelah atas dan di sebelah bawah ni lebih kurang sama. Lebih kurang sama, not exactly the same. Okay. And after that, we are going to calculate here gradient of the tangent at time t, delta v over delta t. Delta v means changes in volume over delta t, changes in time. So macam mana nak kira tangent changes in volume? So kita nampak kat sini ada dotted lines ni, volume 2 and volume 1. So volume 2 tolak dengan volume 1 over time 2 minus time 1. So you will get the answer. This is how you draw a tangent for a decrease in a total mass of reactant. So kalau decrease in total mass, so dia punya graph jadi macam ni. Jadi tangent nak lukis kat mana? Tangent terus lukis di belah bawah ni. Bukan dekat sini di sini. Alright. Contoh soalan. Based on the data, determine the rate of reaction at question number 1, 60 second. Question number 2, 150 second. And question number 3, 210 second. So, untuk instantaneous rate of reaction, kita tak boleh terus ambil daripada data. Contoh 60 second ni, you buat 3.7 divide by 60. Tak boleh straight away macam tu. So, what you are going to do is, first you must plot a graph based on the data you obtain from the experiment here. Okay? And then I pun plot lah data. Okay, ini I guna Excel. So dia macam nampak bengkok sikit kat sini kan. Kalau guna freehand sepatutnya cantik lah kot. Alright, so kira rate of reaction at 60 second. So kita tengok 60 second di mana? Okay, sini 50, 60. 60 dekat sini. Okay, so saya akan lukis tangent di situlah. Alright, so lukis tangent seberapa yang besar saya rasa dia. Yang senang saya nak ambil data juga. Okay, lepas you lukis tangent, buatlah dotted line supaya dia jadi triangle, betul? Okay, so di sebelah dotted line di sini dan sambungkan dapatlah segitiga. Okay, now you're going to use the formula of delta V over delta T. Okay, changes in volume divided by changes in time. So kat sini volume berapa, dekat sini volume berapa. So dekat sini volume 6 if I'm not mistaken, betul? So di sini volume 1. Jadi delta V is equal to 6 minus 1. And delta T kat sini adalah 100 second. So sini adalah lebih kurang 10 second. So 100 minus 10 lah kat sini. Then you will get the answer. The instantaneous rate of reaction at 60 second is equal to 0.056 cm³ per second. Question number 2, calculate the rate of reaction at 150 seconds. So kat sini 150 second. So maksudnya dekat point sinilah. Dan kita lukis gradient. Gradient yang terbaik yang kita boleh lukis. Okay, kemudian kita buat segitiga daripada gradient tersebut. Kan? And then use the same formula which is delta V, okay, divide by delta T. So delta V kat sini kita kena tengok lah. Volume kat sini berapa? 5 cm³. Here is 10 cm³. Okay. So kat sini. So delta V is equal to 10 minus 5. And delta T is equal to 210 minus 80. Okay. Yes. So masukkan dalam formula. 10 minus 5. 5. 210 minus 80 is equal to 130. So the answer for the rate of reaction at 150 second is equal to 0.038 cm³ per second. Question number 3, calculate rate of reaction at 210. So kat mana 210? Sini. Right, dekat sini. So saya pun lukislah tangent. So nampaknya tangent dia tidak berubah tangent dia flat. So bila flat bermaksud reaction dah tamat. So rate of reaction is equal to 0. Now we are going to look at the numerical problem based on rate of reaction. Okay, example number 1. A student add magnesium carbonate crystal until access into sulfuric acid. The volume of carbon dioxide released is collected in gas syringe and the volume of the gas recorded in table for 1 minute intervals for 10 minutes. Okay, ini yang kita dapat, result yang kita dapat daripada eksperimen selama 10 minit and then the volume direkodkan setiap 1 minit lah. Okay, soalan. Based on the table, plot a graph of the volume of gas against time. So, to plot a graph, kita tengok soalan, graph of volume of gas against time. Jadi, volume of gas ni kita akan jadi dia sebagai title di part CY. Time akan jadi title di part CX. And don't forget the unit. Okay, ini this is how your graph will look like. Alright. Okay. To draw the best graph, first you must use pencil. Sebab apa kena guna pencil? Sebab bila ada kesalahan kita boleh padam. Okay. Second, the size of the graph must at least half of the graph paper. Okay. Kalau graph tu kecil sangat, awak boleh ditolak markah lah. Dia tak berapa nak accurate. Okay. Number 3, title at the y-axis and axis with a suitable SI unit. So macam tadi, volume of gas is centimeter cube and then time in minute. And then the scale must be consistent. Consistent maksudnya kat sini macam 2, 4, 6, 8 consistent lah kan. Ni 0, 10, 20, 30, 40 consistent lah. Question, calculate the following average rate of reaction for the 5th minute. So average rate of reaction for the 5th minute yang ni lah minit ke-5. So kalau dia kata 5th minute, maksudnya minit ke-5 tolak minit yang ke-4. So formula that you will we will use is total volume of the gas collected from the 1st minute to 5th minute divided by time taken. Therefore, yang inilah kita highlight kan. Masukkan dalam formula volume of gas 63 minus 58 over 5 minus 4. So is equal to 5 centimeter cube per minute. Okay. So jawapan akhir jangan tinggalkan dalam bentuk fraction macam ni. Mesti convert dalam decimal. Okay. Next question. Calculate the overall reaction. So kita tengok dekat sini. At minute 7, the volume of gas is 70 and selepas tu minit-minit seterusnya dia punya volume tidak berubah. Means that the reaction stop at minute 7. Therefore, kita akan ambil total volume of gas collected divided by time of reaction. So 70 centimeter cube divided by 7 minutes is equal to 10 centimeter cube per minute. Next question. Based on the plotted graph, calculate the rate of reaction for second minute. Okay. Ini maksudnya adalah instantaneous rate of reaction because it is from the graph. Ni graph yang kita dah plot tadi. So, calculate rate of reaction for the second minute. So, second minute dekat sini saya dah tandakan. Jadi, kita akan lukis gradient di sini. Ambil pembaris, ambil pensel dan lukis gradient yang terbaik. Okay. Awak boleh dapat. Kemudian sambungkan dia supaya jadi segitiga. Okay, dotted line lah. Guna pensel lah semua ni. And then kat sini kita akan jadi delta V. Bawah ni adalah delta T. Okay. So dekat delta V ni, V2 is equal to 60. 4 something like that. V1 is 20. So delta T is 4 minus 0.2 minutes. So masuk kat dalam formula yang ni. Jadi jawapan akhir you dapat 11.58 cm3 per minute. So your answer can be in the range of plus minus 0.02, 0.03 macam tu. Okay. So example number 2 ni saya tinggalkan untuk awak cuba buat lah. Okay, dia bagi awak soalan, dia bagi awak data, kemudian dia suruh awak lukis plot graph on volume of gas against time. So part CY volume, part CX time, mesti letak title. Okay, second, you calculate the following average rate of reaction. To calculate the average rate of reaction, kita terus ambil daripada data yang kita dapat. Okay, number 3, calculate the rate of reaction at the following time. Yang ni adalah instantaneous rate of reaction. So, to calculate instantaneous rate of reaction, mesti based on the plotted graph. Okay, so that's all. Selamat mencuba.